Wanted to welcome you to the first video in the series of video lectures for the statistics course. We're going to go through these. You're going to see a little bit of my face, unfortunately, for a little bit, just so you can, I don't know, make some sort of connection with me, the instructor, to the content. This first lesson we're going to look at is on data collection. We're going to go through this pretty fast. Really aren't a lot of problems to solve per se, so a lot of it's just vocabulary and just getting a sense for what statistics is. So the first part is we've got to collect data. And we need to be able to, the objectives for this entire chapter, we need to be able to differentiate between the two branches of statistics. We have descriptive and inferential. For the first part of the course, we're going to be looking primarily at descriptive type statistics. And in the second half of the course, we primarily look at inferential statistics. We're going to identify different types of data. We've got qualitative data and quantitative data, or categorical data. We have discrete and continuous. And we need to identify the four types of sampling techniques. We have random sampling, systematic sampling, stratified sampling, and cluster sampling. And then to be able to explain and recognize differences between an observational study and an experimental study, because the conclusions we draw from those two different types of studies are completely different. And that's really important. That's a huge part of the entire course, actually. So we'll be hitting a lot of these objectives, not just in this one chapter. It'll make more sense when we actually start looking at studies and saying, is this an inferential study? Can we make an inference from this? Is this an observational study? Is this an experimental study? So I'll kind of do a little bit here, but it'll really begin to hopefully hit home with you when we actually begin to do these within the course. And the last objective, I think, is to explain and recognize the misuses of statistics. We all know that people can use statistics to sort of lie, right? They can kind of make their case for something by manipulating the data, or by manipulating how charts and graphs look, and even by manipulating the original questions that are asked in surveys and things like that. So we will look at that. So what is statistics? We all have a sense for what it is, but a couple definitions I like are: statistics is about how to think clearly with data. Another one is, and I like this one, is the art of distilling meaning from data. You're going to be looking at this set of data points or observations, and well, what does this mean? How can we interpret this? Data have a story to tell, and our objective is to uncover that story. So in a word, a lot of times we like to summarize certain disciplines with one word, right? One or two words. So economics is about money, why it's good. Psychology, why we think what we think. Biology is life. Anthropology, who. History, what, where, and when. Philosophy, why. Engineering, how. Accounting, how much. Statistics is about variation. Data vary. People are different. We can't see everything, let alone measure it all. And even what we do measure, we don't measure perfectly, right? So the data we end up with is at best an imperfect picture of the world. This fact lies at the heart of what statistics is about, right? How to make sense of it is the primary challenge that we'll grapple with in this course. So the process of statistics. We want to be able to see statistics as a process. It's not like in algebra where we just solve an equation. We're going to be given a situation. We want to identify the research objective. We want to be able to collect data needed to answer the questions that we actually posed in this first one. And then describe the data, using charts, pictures, tables, and then we want to perform some sort of statistical test called an inference test. And we'll look at those in the second half of the course. So here's an example. A lot of the stuff, and you're going to see lots of word problems in statistics. In fact, this class, almost every problem is going to be a word problem. So you want to get used to being able to read these, right? You want to be able to get used to reading and kind of picking out the parts. You may have to read it through a couple times. I've got to read them through a couple times sometimes to get a sense for what we're trying to do. So let's read through this, and I'm going to it may be painful to listen to, but I'm going to actually read through all of these. This will hopefully help you as you're reading through them to hear me read it and to emphasize certain words, but also for students with disabilities that may have a hard time actually seeing the screen. Okay, so many studies evaluate batterer treatment programs, but there are few experiments designed to compare batterer treatment programs to non-therapeutic treatments, such as community service. Researchers designed an experiment in which 376 male criminal court defendants who were accused of assaulting their intimate female partners were randomly assigned into either a treatment group or a control group. The subjects in the treatment group entered a 40-hour batterer treatment program, while the subjects in the control group received 40 hours of community service. After 6 months, it was reported that 21% of the males in the control group had further battering incidences, while 10% of the males in the treatment group had further battering incidents. The researchers concluded that the treatment was effective in reducing repeat battering offenses. Okay? And so what we'll do in this class is I may give you some data, and you would come to that conclusion. You would see look at the percents, and you would perform a statistical analysis to determine if those percents are statistically significant. At this point, we're just going to go through those steps. So we want to identify the research objective. And the research objective here was to determine whether males accused of battering their intimate female partners that were assigned into a 40-hour batter treatment program are less likely to batter again compared to those assigned to the 40 hours of community service. So that was our research objective that you should have been able to glean from reading that. Okay, go back and look at step 2 and see if you can identify step 2. I don't have these sliding in exactly like I want. So collect the information needed to answer the question. So the researchers randomly divided the subjects into 2 groups, right? Group 1, participants received the 40-hour batterer program. Group 2 received the community service. 6 months after the program ended, the percentage of males and females were determined. The males battered their intimate partner, female partners were determined. Step 3, we organize and summarize the information. So demographic characteristics of the subjects in the experiments and control group were similar. After 6-month treatment, 21% of the males in the control group had further battering incidents, while 10% of the males in the treatment group had further battering incidents. So that's the summary of that study. And then the last step here, we'll draw a conclusion from the data. So we extend the result of the 376 males in the study to all males who batter their intimate females partners. This is the inference part, right? Can we say, and we'll learn about this later, can we conclude that this will work for everybody? That is, males who batter their female partners and participate in a batter treatment program are less likely to batter again. So that's the conclusion we draw from the data. And this is what you're going to end up doing. I'll give you a set of data and give you a couple questions to answer, and then you will come to these conclusions. Identify types of data. So we make a distinction between categorical variables, also called qualitative, and quantitative variables. We sometimes refer to these as categorical data and quantitative data. Here are 2 definitions. Quantitative data consists of numbers, think quantity, representing counts or measurements. Qualitative data, or also categorical data, can be separated into 2 different categories that are distinguished by some non-numeric characteristics. Now, we can't get too confused on this. Just because it happens to be the categories happen to be numbers doesn't mean that it's quantitative, like zip codes and things like that. We typically don't think of that as quantitative. Or if we're doing 1 for males and 2 for females, just because we put numbers in there doesn't mean that's quantitative data. Okay? So let's have an example. So classify each variable as qualitative or quantitative. So the number of bikes sold in a year. And again, I'd recommend pausing before we reveal the answer on a lot of these. It'll just kind of help you make that connection if you're doing that. So quantitative. The number of bikes, what's number of bikes? It'll be like 27, 309, 422. It's a numerical quantity. The color of baseball caps sold in the store. So if you were to list all the types of colors, red, blue, green, yellow, black, white, brown, those are colors, those are categories, right? So that's qualitative or categorical. Either one is fine. So again, these types can help us decide what to do with the variable. But they're really more about what we hope to learn from the variable than about the variable itself. And what I mean by that is the question we ask a variable that shapes how we think about it and how we treat it. And you'll see that later on when we actually begin entering these into software packages or using the TI. Okay, another example. Determine whether the following variables are qualitative or quantitative. So gender, temperature, number of days during the past week, college student age 21 years or older has had at least one drink, zip codes. Didn't mean to reveal that. So go ahead and take a moment to think about these, where you would classify these as qualitative or quantitative. Go ahead and pause it now, and then we'll talk about them. Okay, gender. Gender is going to be qualitative, right? It allows the researcher to categorize individuals as male or female. Two categories, right? So categorical or qualitative. What about temperature? Well, temperature is quantitative, right? It is numeric, and operations such as addition and subtraction provide meaningful results. That's another way to kind of think about this. When we subtract or add the numbers, does it have any meaning? And part C, the number of days during the past week a college student age 21 years or older has had at least one drink. Well, it's quantitative, right? It's numeric. Operations such as addition, subtraction do provide meaningful results. Number of days, 32, 35, things like that. Or hopefully not that many because it's only 1 week. 3, 4, so forth. 0. What about zip codes? Zip codes are qualitative, right? Categorization by location. Addition, subtraction really doesn't provide anything meaningful here for us. And there's the summary of the answers. Okay, identify the name of the variable and specify whether its use should be treated as categorical, qualitative, or quantitative. So here's the example. A listing posted by Arby's restaurant chain gives for each sandwich it sells the type of meat in the sandwich, the number of calories, and the serving size announces. Data might be used to assess nutritional value of the different sandwiches. So take a moment now to identify the list of the name of the variable and then specify whether its use should be treated as categorical or quantitative. All right, welcome back. I know you paused it. I know you did. So the first variable would be the type of meat, right? We've got type of meat. Maybe I can turn on my pen here. We have type of meat in the sandwich. And that is, hopefully that's easy to do, categorical, qualitative. The next one would be number of calories. We have number of calories here. We don't really know what those are. I mean, we're not given the type of meat, but you should be able to kind of imagine that. And the serving size in ounces. So serving size in ounces, that would be quantitative, right? I mean, we're thinking 40 ounces, 20 ounces, etc. And I think I summarized that here. I do. So let's look at quantitative variables. Now, quantitative variables can be actually split into two different types of variables. We have continuous and discrete. So discrete variables have a finite number of possible values, countable values. Like the number of days in a week. 1, 2, 3, 4, 5, 6, 7. That's it. Continuous variables have an infinite number of possible values that are not countable. Like weight is a typical one, because while I can't be 172, really it's 172.3 or 0.34567 or things like that. So the continuous variables can really obtain any value in discrete finite number of possible values, countable values. So in the prior example, we identified the following two variables as quantitative. Temperature and the number of days during the past week. A college student age 21 years or older has had at least one drink. Now classify these as continuous or discrete. So temperature is going to be continuous or discrete. It's going to be continuous, right? I mean, we could obtain any sort of temperature. 30.3, 30.35, 31.7, things like that. So if you think, I guess one way to look at it, if you think about it, if I can start putting decimals on these, and they actually make sense in light of the data that we usually collect, it's more than likely going to be continuous, is another way to look at it. The number of days during the past week college students at age 21 years or older has had at least one drink. We wouldn't say 1.5 days. I mean, they either had a drink that day or they didn't. So this one is going to be discrete, right? We have countable numbers, and I kind of already talked about that earlier. So there's the answers all typed out. Don't always do that, but I did on a few of these. Another example. The Kentucky Derby is a horse race that has been run every year since 1875. Here is the data for some of the races. Identify the variable and indicate if it's quantitative or qualitative. If it's quantitative, indicate whether it's discrete or continuous. And this is the kind of data we'll be looking at a little bit more than the other ones, right? I mean, we're going to be wanting to, or if we have that situation, we're going to want to set it up in some sort of spreadsheet. That's how we end up analyzing the data in statistical software packages. Okay, so look at these and see if you can come up with the answer. Okay, so you may want to organize this in some sort of table, right? So you may want to have year and then winter. So those are the variables. So your variables are generally, not always, these right here at the top. So when I'm thinking variable, I'm thinking I'm going to be creating a column. So year, that's a variable. And then we want to identify the variable if it's quantitative or qualitative. So is year quantitative or qualitative? Is what the question you want to ask yourself. The same for all these other ones, for winter and for margin. And then if it's quantitative, indicate if it's discrete or continuous. Okay. So I've got it set up in a little table. We got the variable. I've already given that to you over here. I assume you can look at those once I explain that. Now, I think this all comes in at once, so let's just talk about this. So year, you think it's going to be quantitative or qualitative? It's going to be quantitative, right? We're talking about a year. It's a number. And addition and subtraction of years actually makes sense. What about the winter? Got a fly in here. A winter, we're talking about a person, right? Or a horse. So it's going to be categorical, right? So go ahead and think about those and each of those and see if you can come up with that. Go ahead and pause the video. Welcome back. I know you paused it. I know you did. So let's go ahead and reveal the answers here. Does that make sense? Jockey, qualitative. The net to winner is quantitative. We're talking about the amount of money that's given to the winner. The duration, how long it actually took, is going to be quantitative. And the track conditions is qualitative. And then we hit, for our quantitative variables, the year is discrete, countable number. It's happening in specific years. It wouldn't happen in we didn't say it happens in 1996.2 or something like that, right? You can have fractional parts of a year, but that's not how the data are recorded in this particular context. The net to winner is discrete, the countable amount of money that's given. And the duration is continuous, right? We could end at any possible moment, so that is continuous. So just some examples of descriptive statistics.